You get a chatbot, and you get a chatbot, and you get a chatbot. Everyone gets a chatbot. But why? And once you decide you want one, what's the best way to get one for your OutSystems app? Find out next on this episode of Decoded Quick Hits. So I wanted to share that this particular video was a little more challenging than others to get produced, in part because this happened. This is Micah. She's a 9-week-old Norwegian elk hound, and she just joined the Duthie household in the last week or so. She is just as cute as she looks in the picture, even more so in person, and has kind of blown a puppy-shaped hole in our schedules and routines. Chatbots provide a different way of interacting with back-end services compared to traditional websites and apps. A fancy way of putting it is that chatbots are part of multimodal application experiences. Another term you'll hear used sometimes is conversational UI. The idea is simply that you interact with a chatbot as you would with a person. You make requests or ask questions, and the chatbot uses software to decide how to respond. A chatbot can also be made available in places other than a typical website or app, for example in a Slack channel or a Facebook bot, which means that it's easier for users to get access to it. Now, as I was developing the demo for this app, here in the US, we were celebrating St. Valentine's Day. So let's imagine that I've forgotten to send flowers to my wife, and the big day is rapidly approaching. And maybe I need a quick way, in context, to find and send flowers to my wife. So maybe a chatbot? For a traditional business case, chatbots can be used for everything from fulfilling user requests, customer support, and frequently asked questions. But once we've decided on a chatbot, what's the best way to implement it, particularly for the OutSystems developer? I think a great option is Amazon Lex. Amazon Lex is a chatbot service that's based on the concept of intents. Intents are the basis of interaction with Amazon Lex, which supports both voice and text. An intent is simply what the user wants to accomplish and is configured with one or more sample utterances, which are what the user might say to access this particular intent. In my case, the intent would be to order flowers, and a sample utterance might be, "Help! I need to get my wife flowers or I'll be sleeping outside tonight." Maybe not quite that dramatic. Intents can also be used across multiple bots, providing a path to reuse. An intent can also include one or more slots, which represent options or parameters for the intent. Amazon Lex asks the user for this information with configurable prompts. So Lex could ask me what kind of flowers I want, and I could say roses or carnations. Similarly, we could have prompts for how many flowers, where they should be delivered, and so on. And while an intent can be completed with a simple text response, it can also leverage AWS Lambda functions to perform validation and fulfillment of a given intent. In this way, we can take an operation with several steps, break it down into the steps and options, and we can walk the user through it easily in a conversational fashion and handle their requests easily. The demo app I've built is broken into 4 basic parts: creating and configuring the bot using Amazon Lex, and wiring that bot into my OutSystems app, creating a data entity and a REST API on the OutSystems side for storing my flower orders, configuring the bot to use a Lambda function to call the API to save each individual order, and finally, creating the app screens to enable interaction with the bot and view the existing orders. Let's take a look at a demo. So we'll start our tour of the demo application in the Amazon Lex console. So obviously I'm logged in, I've got an Amazon account, and I've set up Amazon Lex. The home screen for the Amazon Lex console shows me the list of bots that I've got created currently. And so I've got a book trip, a save me, and schedule appointment. We can look at these in a little bit. There's also a create button, so I can create a new bot. You'll also see on the left-hand side that I've got things like intents. Again, I noted that the intents actually can span applications, so you can share those across different bots that you might have, as well as slot types and the ability to switch over to the V2 console. I haven't jumped over to that one yet. So let's jump into the create UI. So when I go to create a bot, I can create my own custom bot from scratch. I can also use an existing sample. So there's a book trip, a schedule appointment, and order flowers, which is what I used for the basis of my particular application or demo. And you can see that when you choose the different samples, they kind of show you sample interactions of how you might have the intent, which is to order flowers, the various utterances that might be spoken or typed, and then Lex will interpret those utterances using natural language processing to figure out what the user wants to do. The slots represent the parameters or the kind of options of what the user might want to do, and then Lex will prompt based on those slots and the configured text that you have for those given slots. Last but not least, fulfillment is the step at which the intent is complete. And again, that fulfillment can be completed by a text utterance or a text response from the bot, or it can be done using an AWS Lambda function. And for each of these sample bots, Amazon also includes sample Lambda functions that you can slot in very easily and customize to your needs. Additionally, there are options for language. So mine would be English US, but yours can be whatever you would like it to be, appropriate to your region. You can also enable sentiment analysis. So that gives you the ability to determine based on the utterances or what the user types or says, what their sentiment or their mood is. You can configure the role that you want your bot to be executing in. You can say whether your bot does or does not have COPPA, the U.S. Children's Online Privacy Protection Act, applicable to it. You can learn more about that here. You can also add any tags you want and modify the confidence score threshold for the interpreted response. So I'll cancel out of this and go back to my pre-configured bot. Now, my bot, as I mentioned, is the dramatically named Save Me. So save me from sleeping outside because I didn't remember to order flowers. And it's using that order flowers sample. It's got slots for flower type, pickup date, and pickup time. And I can hook up a Lambda function for initialization and validation. I don't have that here. You can see the sample utterances. I'd like to order some flowers. I would like to pick up flowers. Based on these sample utterances, again, the AWS Lex service will perform natural language processing on whatever it is that I type into the chat and see how confident it is that it will match one of these sample utterances. I can also have confirmation prompts. So you can say, once I need to confirm that all of the slots are filled and that we fully understand that what the user has requested, you can say, okay, your flower type will be ready for pickup at the pickup time on pickup date. And does this sound okay? And then if the user says no, okay, I won't place your order. And then once the user confirms, we can do one of two things. We can either return some information to the client, or in my case, I've wired up an AWS Lambda function called order flowers code hook, which is just a simple Python function that's going to call back into my OutSystems application and allow me to store a record of that flower order. And the version or alias for that AWS Lambda function is just going to be whatever the latest version is. And last but not least, I want to have a response to my user. So in this case, I'm just going to use the message, thanks, order placed. I could also have a response card, so I can include graphics and things like that. And also wait for the user reply. Once I've got everything that I want to do for this particular order flowers intent in my bot, I can save that intent and I should be ready to go. When I'm ready to test my chatbot, there's a test window here, but I will sometimes need to build my chatbot first. So I'd click the build button. In my case, my bot's already built. And then when I'm ready to use it in my application, I would publish that chatbot as well. AWS, as I mentioned, helpfully provides a test response here. So I can say, I need flowers. And I should get a response here. What type of flowers would you like? And I can say, roses, and let's say I want to pick up the roses tomorrow. And one of the nice things about the bot here is that I can provide a specific date using, say, I could say March 16th, since today is the 15th, or I can say tomorrow, I could say 2 days from now, I could say next week. So the natural language processing makes it easy for me as the end user to use whatever terms make sense to me and have Lex do the rest for me. So I could go through the rest of this. I'm going to skip the rest here, but you can see it picked up flower type roses. It picked up the pickup date, and then I could say, what time, etc. Now that our bot is successfully configured, built, and published, we need a way to connect it to our OutSystems application. We do that using the AWS Lex Chatbot connector found in the Forge. You can see the listing here, And on the documentation tab, you'll see some supporting presentations and documentation as well. Some links to a supporting video, as well as links to the Amazon Lex documentation as well. Switching over to the Service Center listing for my AWS connector, you can see that we have the access key, the region name, the secret key, and the service name. All of these are configured at the environment level to allow my application environment to connect to my specific Amazon Lex instance. Note that we've obscured the effective values for our keys because these are secrets that you don't want to share with others. In addition to configuring the access keys and other information for the connector itself, I also need to go into my application module, and I have several site properties I've set up, including the bot alias, the bot name, and the display name for my bot, so that those are accessible within my OutSystems application as well. Those aren't required by the connector, but those are conveniences that I'm using to make it easy for me to switch those around and save those using different values for different environments, say development versus production, development versus testing. Once I have my connector installed, the site property is set, I'm good to go to get into my application itself. In addition to having my application interact with Amazon Lex to provide responses to text or voice input, I also want to have Lex be able to interact with my backend of my application to store flower orders. In order to do that, I need to have some place for that data to go. And so I've created this flower orders entity, which has the properties of flower type, pickup date, and pickup time that correspond to the slots in Amazon Lex. So each time Amazon Lex detects that a user wants to place an order, the Lex intent or the fulfillment of the Lex order will actually call back into my application and save that data using a REST API that I'm setting up around this data entity. Switching over to my logic tab in my application, you can see that I've created a simple REST API called flowers with one method, post order. And you can see that it's going to use the URL flowers fast, the name of the URL for my application, REST, flowers, and post order. It uses the post HTTP method, and it's going to expect arguments for flower type, pickup date, pickup time, as well as having a local variable for flower order with those same properties of the data type of my flower orders entity type. And if we click into post order to look at the flow, you can see that we're going to map the flower order input parameters into the flower order local variable, and then use that to call save flower order, which is a simple server action that's going to call the creator update flower orders. Now, the reason I'm using a server action here is because we don't want to be saving information directly to the database without any validation. In a normal application, I would surround this with some validation, make sure that the person saving the information was authorized to do so, etc. But I'm just going to call save flower order, call create or update flower orders, and update the data entity with the appropriate values from the Amazon Lex service. Now, to take advantage of the data entity and REST API I set up on the OutSystems side, I need a way to call into that from my Lex bot and fulfill the intent. So I do that again using a Lambda function. So right here, we're seeing the AWS Lambda home screen or the console for the AWS Lambda service. Lambda, for those of you who may not be familiar with it, is one of a variety of services that are sometimes referred to as serverless, which is a bit of a misnomer. But the idea is that you don't bother setting up a bunch of complexity or standing up a server to do some work. You can simply create individual functions that you can call from a variety of other services in order to do the work that you need to do. So in this case, I've got 3 Lambda functions set up. I could create a new function. And one of the cool things with AWS Lex and Lambda is that there are a number of recipes for AWS Lambda functions that key into some of the sample AWS Lex bots and allow you to fulfill the requirements of those specific sample bots. I've used that to create my individual Lambda functions. So if I click through, you can see the first one here. Actually, all of these are based on that same recipe, but I'm using the one currently called order flowers code hook. You can see I last modified that last week. Go ahead and click into that. And you can see you've got a number of options here. You can see the code source, you can test your Lambda function, you can monitor it to see how it's being called. And if we look into the code, the main thing I want to look at here, so this is a Python function, and if we dig into it a little bit, the main thing I want to see here is the part that I've added is in this section here, where I'm using an HTTP library that's available for Python. And so I'm calling in and making a post request. I'm posting to my application, my Flowers Fast application. And in the headers, I'm posting the flower type, the date, and the pickup time that come out of the intent. And those are actually automatically pulled in to the Lambda function when it's called from AWS Lex. So really that's how I've wired it up into my OutSystems application itself. And if we go back to Lex briefly, just a reminder, we wire this in the fulfillment portion. We check the AWS Lambda function radio button and we select the order flowers code hook. You can also see the other AWS Lambda functions that I have available here. Once you've selected that, this gives you a direct link over to the Lambda console if you need to edit or view the code for your Lambda function. Now that we've got our Amazon Lambda function wired up for our back end, let's take a look at how we can start our UI interaction. So I've created a screen here called FlowerBot, and it has some local variables for input text, chat messages, and user ID. Chat messages is a list of the chat message structure type. That structure type looks like the message is from bot, which is a Boolean, the date, the time, and the sender name. So what this allows me to do is have a list structure on screen. So I've got my chat message in a container, and then that list of chat messages that is bound to that local variable of chat message. So each time a chat message comes in, I can add it to this list and it will be rendered in that UI automatically using reactive. Also including the user ID, and I've got the input text for a text box down here, which is where the user will type their input message. When the user types their message, they'll click on the send icon, which is inside of a container that has a click handler for the send message client action. We double click here. We can see this action. If I don't have any input text, we'll provide an error message that says to type a message and end. If we have input text, we'll assign that to the input text local variable here. We'll add the user's message to the chat messages local variable or that list using the text message. The is from bot is false, the current date, the current time, and the sender is me. And then once we've added that, we're going to call into the Amazon Lex service using this send text simple message server action, which is exposed by the Amazon AWS Chatbot connector here under the send text folder. So I've got send text simple message, just drag that in here. And inside my flow, you can see I've got the bot name set up in my client variable, bot name. Bot alias is client variable bot alias, message is the text message, and the user ID is my user ID. So we'll send those all over to Amazon. If we get an error back, we're going to add the message to the list. We're going to pop up an error message to the user and end the flow. If we get a valid response back, we're going to add that bot response to the list of chat messages, and then that will update the UI with the bot's response to me. And then we carry on from there. So the last piece of UI that I wanted to show you before we jump into the live demo is the order screen. And the order screen I simply created by going to my going to my database, finding the data entity and dragging it onto the screen. Really, this is just a means of being able to show the user the orders that are in place currently, and very, very simple. It's just a list UI with the flower type, the pickup date, and pickup time. Simple as that. I also added in a swipe action to allow me to, just for demo purposes, delete an order very easily. And of course, I also added some menu items under the hamburger menu to be able to access the different screens. So pretty straightforward. Notice that my application's only available for registered users. It just means I have to log in. I could make it available for anonymous, but obviously in a production application, that's probably not the way that I want to do things. So let's jump over and try the application. Once I've created my application, there are a couple of different ways that I can test it. One is I can just test it in the browser, which is pretty straightforward. I can also switch over to the Distribute tab here and turn on this Distribute as PWA toggle. And once I've turned that on, I can simply scan this QR code from a mobile device and actually access my application as a PWA directly on my mobile device. I'm going to stick with testing in the browser right now, so we'll just click through. and jump into our application. Once my app loads in the browser, OutSystems provides a simulator that allows me to view my application just as it would look in a standard mobile device. We're on the home screen, and I can click the button here to start my flower order, or I could use the menu to view existing orders or go to the flower bot from there. If I click the flowers button, that will take me to the order flowers screen with my bot. So I can say, I need flowers fast, and send that. And the bot should respond with, what type of flowers would I like? Well, I'll get my wife some roses. And I'd like to pick those up tomorrow. Actually, let's pick those up today. And we'll pick them up at, let's say 4 p.m. And the bot responds, your roses will be ready for pickup by 1600 on 3/17. Does that sound okay? Yes, that sounds great. And it should say, orders placed. Okay, great. So now that we've got the order placed, we can go up to the menu, check the orders, and we can see we have an order for roses for the 17th of March 2021 at 4 p.m. Terrific. So now we're good to go. So in this episode, we walked through the Amazon Lex connector. We hooked it up to an OutSystems app, both front end and back end, and learned how we can use bots a little to more effectively interact with our users. Hopefully you see how simple it is to use Amazon Lex with an OutSystems application, and I hope you enjoyed this video. If you enjoyed it, please give us a like and subscribe to the OutSystems YouTube channel. And be sure to click the bell icon to be notified when we post the next episode of Decoded Quick Hits. Thanks for watching.